Good afternoon, everybody. It is great to see how many of you have joined us here today. Welcome to this webinar, hosted today by Valvitalia. The speakers today are Giovanni Appa, Commercial Director, Deputy General Manager, and Marco Pesaola, Technical Director and Operations Director Division from Vitalia Firefighting Division. Giovanni graduated in business administration at the University of Milan in 1994. After a few years' employment in his family company, he started his career as a manager in the energy sector during the Italian liberalization phase. Giovanni has a long experience in business management, covering different management positions during his career. He joined Valvitalia in 2016 as Group Business Development Manager. In 2017, he entered in the firefighting sector as General Manager of Silvani Division, part of the Valvitalia Group since 2018, as a consequence of the merging of Silvania and Ubisabi Division and the establishment of Valvitalia Firefighting Division. He became Commercial Director and Deputy General Manager of Valvitalia Firefighting Division. Marco is a member of the Italian Minister of Interior's list for firefighting engineers. He was a graduate in mechanical engineering at Aquinas University and serves in several technical committees dealing with gas and water-based firefighting systems. In 2009, he became Business Development Management for the high-pressure water mist system and developed new business opportunity in marine, oil and gas sectors. Since 2019, is the Operations Director of Valvitalia Firefighting Division and coordinates engineering project management, quality, HSE teams. We do encourage you to ask plenty of questions at any point during the webinar. Please type your questions into the Q&A box you will find at the bottom of the screen. At the end of the presentation, we will present your questions and answer as many as possible. It is a pleasure to have Giovanni and Marco with us today, and I would like to warmly welcome them now to take control and begin the session.
Thank you, Martin. Thank you very much. My name is Giovanni Appa, as Martin said before. I'm very happy to be here today with you, and it is a very new experience for me and for Marco to join this kind of webinar. So I hope that you will enjoy our presentation. There will be two presentations. I will start with the general introduction of the Valvitalia Group and with the focus of the Valvitalia Firefighting Division. And then Marco will enter more in detail on the train application of our systems. You can see from this chart that Valvitalia is an Italian company. We are based in Italy, and we have two very big shareholders, one family owner, so family Ruggeri, but we are in our shareholders also a very big important Italian company, the CDP Equity, that is an investment fund of this they called Cassa Depositi e Prestiti, that is Italian investment for Italian fund for investment, for strategic investment. Our group turnover in the last year, 2019, is about 304 million, and we are about 1,120 people. The growth of the company has been very, very fast in the last 18 years. It's a relatively new company. It's been established in 2002 by Mr. Ruggeri and his sons, and then grow throughout the years for acquisition and grow of its market, especially in the oil and gas market. You can see the couple of drop during the year in 2010 and 2018, according to the crisis of oil and gas sector mainly. The growth of the employee is following the growth of the turnover. So actually we are about 1,100 people. We are Italian-based company, but we sell our products basically worldwide. You can see in this chart that we sell the products in 113 countries all over the world. Basically, really just a few states missing from our sales. We are approved by the major important contractors and end users. You can see here some brands of our customers in different sectors, oil and gas, power plant, naval, railways, infrastructures. So we are worldwide recognized as one of the major producer of valves, fittings, flanges, not only firefighting, of course. This is our field of application that this chart you can see also in our website. And you can see that we can sell our products basically in all the different application. So of course, the oil and gas business is our core, maybe business line, but we sell also in different other fields, and especially the firefighting, we can enter in different market than oil and gas. The company is Italian, as I said before. We have 10 manufacturing plants, 7 are in Italy, but 3 are abroad, 1 in UK, 1 in Canada, and 1 in China. And then we have 3 representative offices in the major market for the oil and gas, or Houston, Abu Dhabi, and Algeria. Now I will give you an update of the firefighting division, because in Valvitalia group there are different divisions, actually business unit, and one of these is Valvitalia firefighting division. It's been established by the merging of 2 historical companies. Maybe someone of you knows Silvani and Eusebi. Valvitalia decided to enter in the firefighting sector in 2014, purchasing Silvani, and then in 2015 purchasing Eusebi. During the years from 2015 up to today, we merged the 2 companies that were 2 independent companies, very old companies, especially Silvani has been established in 1938 and Eusebi later in 1972. So there were 2 independent companies, 2 competitors also, and after the purchasing of Valvitalia in 2014 and 15, we merged into 1 division. So in April 2018, has been established the firefighting division that nowadays is the biggest Italian firefighting company on the market. This is how we are organized. Our headquarters is in Ancona. That is an area here in the center of Italy. You can see the video, picture of our plant area, about 30,000 square meters. We have a very big testing area that you will see at the end of my presentation live, and we are about 170 people. The headquarters is in Ancona, but we work not only in our headquarters, but also throughout many yards. Especially you can see in this figure the Italian yards, but we have also 2 abroad yards. These one are the one that we work with the Fincantieri and of course with Trenitalia. Marco then will go in details one of these plants. Our business model is can be starting from the bottom of this chart, simple supplier of products. So you have a video, a photo here of our monitor, of our nozzles. But basically we are system integrator. So we assembly in our warehouse, in our plant, what we produce and what we buy from other suppliers, taking care of all the engineering and procurement activities, but many times also of the installation, so also the construction activities. That's why we are an EP and EPC company. Like system integrator, we can supply all the subsystem available to the market. I will show you later on our products, and also a full project package to our client. Sometime when the customer requires, we can also start to cooperate like a partner since the beginning, starting from the feed phase. What we sell? We sell basically 6 product lines. So we have the skid systems, the gas suppression system, the water mist system, fire and gas detection and alarm system, firefighting equipment, and firefighting vehicles. I will give you a snapshot of this product in the next few minutes. This is our markets. So very important for us is the marine sector, but also the train. I will skip the train because Marco will go focus on this one, but marine, all the military and cruise ships, we are able to supply many of our systems. Oil and gas is, of course, the core business of Valvitalia, and so also one of the most important sales channels of firefighting division, but we are very active also in infrastructure and civil industrial activities. Now I will go very fast to the product description of our firefighting division. Those are the skid systems. They are designed, produced, and generated in our company, and they are compliant with all the regulations of each country where they need to be installed. We can have also the UL, FM approval, VDS approval. So we are very specialized to all the requirement of the market. This is maybe the most common firefighting system, the gas suppression system. Again, here we take care of all the hydraulic calculation, engineering, design, and then we finish to the test and the commissioning of the system on site. We are able to supply all the gas available on the market, so Novec, Energas, CO2, FM200. This is the maybe core product of Valvitalia firefighting division, the water mist system. We are one of the few companies in the world able to produce, to design, to supply this kind of systems. And this is used on the trains, like Marco will explain you later on. This is the classic system of water mist, of course, is for the shutdown of the fire, but there are also some special applications, like what we call window washing system, that are these systems used to clean the window of the ships, or the cooling system that is the one that you see in the bottom part of this chart that is installed now in the metro of Riyadh in Saudi Arabia. The fire and gas detection alarm, this is made in our plant, is designed by us, is a fully configurable systems, modular, and is very, very strong compliance with many of the regulations available worldwide. We call CS 400. Then, okay, this is the firefighting equipment. Some of these we produce. We are very proud to produce the biggest monitor in the market. We call Jaguar, is able to the flow rate of about 60,000 liters per minute. Some of these we make, some of course we trade because we have a very long history on the market. And then finally, this is a very niche product, the firefighting truck vehicles, the trucks, that are very, very particular just for the refineries. We buy the chassis from the major producer and then we set up all the firefighting equipment. So I just take 10 minutes to introduce the company and the products. And I will leave now with the video of our testing area, because as I told before, we have in our facilities one of the biggest testing area in Europe. So luckily, maybe not many of us have seen in function the firefighting system, because if this happens, it means there is a fire in place. But we test all our systems, and so now I will leave you with this video, and then the floor will be of Marco. Thank you again, and I'm here for any question and answer you need to give us. Thank you very much. Marco.
Marco, can you unmute, please?
Yeah, thank you. Good morning, everybody. I hope that everybody can see my screen properly. Thank you for giving us the opportunity to present this challenging project that we have realized on board one of the most prestigious high-speed train in Italy, and I think in Europe. So thank you for all the qualified audience that joined us today. Okay, let's speak about the background of this project. The need to have fire detection and firefighting on board trains in Italy starts from a law that was back in 2005. So basically, according to that law, each train traveling across tunnels longer than 1 kilometer shall be equipped with fire detection and firefighting. And so after that, according to the previously existing ARGE guideline, was developed a national standard, an Italian standard, the UNI 11565, that is completely dedicated to fire detection and fire extinguishing on board train. And this standard deals with the design, installation, validation, and maintenance of these kind of systems. The Italian standard also requires that the system is approved and qualified by a third party that is also well described in the standard. Also, we have not to follow only this Italian standard, but for this specific project, also two main specifications issued by the Italian operator, the main Italian operator, Trenitalia. So, of course, the operator issued this standard in order to have a sort of common features between all the firefighting systems installed on board their fleet. So, okay, consistent with Italian standard and all the other applicable standard, but also for other parts, all the system should follow some strict specifications. So the first specification is totally dedicated to the control system and detection system. It is this specification is commonly called SHIA. And another specification clearly describes the main details of the detection and extinguishing system that can be installed on board the various species of a vehicle. So what these specifications are describing specifically as from point one, a modular control system equipped with redundant controllers. So because of course on board the train, redundancy of the main controller is very important. Then also passenger compartments as well as toilet have to be equipped with the water mist system and relevant detection system. While the many technical spaces and technical lockers on board the train have to be equipped with fire detection also and an extinguishing system that could be aerosol or any suitable gas extinguishing system according to the European standard. In our project, due to the particular technical spaces, we designed aerosol system with thermal cables as detection system. So those specifications also have a strict requirement for what concerns the detectors. So the detectors have to be very smart. Their output have to be serial type in order that their threshold can be set at different levels according to the project requirements and the different areas that are on board the train. So, for example, in the area of the entrance doors, there is the possibility to have the presence of more smoke, or in the galleys and in the kitchen, of course, the threshold have to be adjusted. So for both smoke and temperature, the detectors that we have used can be modified and calibrated also according to the tests that have been done after the installation of the system. Also, the detection have to be able to detect all possible type of fires, because we can have fire created by cable, by luggage, or even by fuel if there is the possibility of an arsonist. So there are different type of detectors located in different areas. So in the passenger area, we have thermal and smoke detection, while, for example, in the toilets, we used flame and thermal detectors, of course, in order to avoid false alarm. But what is important is that all these detectors can be set at different thresholds in order to cancel any possibility to false alarms. That, of course, is of paramount importance on board the trains, because we can have dust, fumes, and condensation and other environmental issues that can create false alarms. So specifically, we designed and produced and installed a modular detection system and a fire extinguishing system that is composed in six main parts. So the redundant controllers, it means that in each wagon of the about 650 the fleet is composed of, we have in each wagon 2 redundant controllers, a set of module that controls all the extinguishing system and the detectors. There is a communication CAN bus between all the modules and the controllers. Of course, also the power supply is redundant, and the firefighting system has been designed in order to limit at the maximum the amount of water needed for the extinguishing activity, because of course on board such vehicles, and this one in particular was an existing fleet of train, of course is very important to limit the space needed to locate the firefighting equipment. We are seeing now a very general scheme of the system. So we can see on the left that we have a space where the water mist equipment is located, and along standard type of coach, there are in this fleet, in the ETR 500, there are several type, of course, of coaches. There is the standard coach, the economy coach, the business. So we have to basically design five different configuration, but this is the most standard. So as we can see, the passenger area is divided basically in 5 zones. Each zone is controlled by a nozzle, and the water mist discharged by the nozzle is activated by a control valve, and the control valve is totally monitored by a dedicated module. So when I speak about modular configuration of the control system, exactly this is the meaning. So each zone is controlled by a module. Also the extinguishing equipment, the water mist package, is controlled by its own output module, and the water mist system dedicated for the protection of the toilet that you can see on the right of the picture is monitored and managed by its own module. So in total, more or less, we have about 8 water mist nozzle in each coach, and about 15 detectors. We will see better some details about that. Now we can go more in detail regarding the modular configuration of this equipment, and we can see that we have different modules in the control system. So the V type on the top are the modules dedicated to receive signals from the fire detectors and activate the relevant zone valve. So they have a very important task. Then we have the W ones that are slightly different, but are dedicated to the toilet, receive signals from the detectors in the toilet and activate the water mist, the relevant water mist system. There are other ones that are dedicated for the technical spaces that receive signals from the thermal cable and activate the aerosol, and other ones that are only dedicated to detection. Another one is called the output module and receives signals from the controllers, and when there is actually a fire, have the task to activate the firefighting system. This is in general how the system is designed. So all the modules that we have seen are connected by a redundant CAN bus. So in case of fault in any part, the system is still alive. We have the 2 controllers connected by CAN bus. The 2 controllers are a dialogue with the train with a double Ethernet connection. So all the coaches are connected together via Ethernet, and all the information are also sent at the maintenance location of Trenitalia by a web app that we have designed. So all the alarms and all the faults also are transferred by web to a cloud and then to the maintenance facility of Trenitalia. So this is a brief list of this of controllers and modules. I would like to focus on the detectors. In this project, one single detector is able to measure 3 characteristics of the fire. The same detector can actually receive smoke, temperature, and temperature gradient. So also can measure in the variation in the temperature in 1 second. So combining these 3 characteristics, the controller is able to detect if in the case there is just a pre-alarm, or actually there is the condition of fire. So the system can start the extinguishing in, for example, zone 1, that can be at the beginning of the coach, or in zone 3, that is in the middle of the coach. So combining these 3 measurements, the system is able to activate 1 single zone up to 2 zone maximum. So 2 continuous zones, it means 2 nozzles at the same time can be activated when fire condition is detected by 2 detectors that belong to different contiguous areas. Here are, and in this slide, we can see how is the distribution of the modules in a standard coach. So the V type are for the passenger areas. W is the one dedicated to toilets. The air type is where there is only detection. That is typical for in the driving cabin. So let's focus a little bit on that, because the control system is one of the main part of an automatic firefighting system on board train. We have the air module dedicated only to detection, and we have the W for the toilet, where we have, differently from the other areas, also flame detectors and a dedicated cylinder for the water mist firefighting system. And then we have the V modules, that is the most common one for the passenger areas. They can receive signals from the detectors and activate the relevant zone 1. And then we have the T modules that controls the aerosol and the thermal cable for the technical space. Let's see now how the detectors have been installed on board the coaches. In each zone we have 2 detectors, and in the middle we have 1 nozzle. As we can see on this slide here, each nozzle is controlled by its own selector valve, and then the relevant module. So what is important is that each of these detector is very smart, can measure 3 different environmental characteristics, so temperature gradient and smoke, and continuously these are evaluated by the controller to understand if there is a fault, or we can have a pre-alarm or an alarm condition. Regarding the fire suppression system, we have nitrogen cylinder for the propellant needed to pressurize the water, and a water cylinder. At the end of the design, the amount of water stored in the water cylinder has been limited by successful fire tests to 80 liter. While in the technical spaces, we can see each technical spaces that needed to be protected by fire detection and fire extinguishing according to the Italian standard. We have 1 or 2 aerosol modules, and these are activated according to the fire condition detected by a thermal cable. The reason for the choice of water mist in this application actually is due to the very fast level of protection that you can achieve in very few seconds when the water mist discharge starts. Also, the water mist floods entirely the wagon, providing cooling, inertization, and screening of the fire. So it is very important to achieve the 15 minutes of tenability of the coach that are required by the standard in order to protect passengers for a minimum 15 minutes. The higher pressure system that we have installed ranges from 60 bar minimum at the nozzle and a maximum of 120 bar. So the main 3 tasks that we faced for this project are the fire detection that I have described before, because I have to be very fast, of course reliable, and most of all localized. So have to be very smart in understands and indicating where exactly the fire is in the 5 zone each coach is divided in. Of course, in the water mist system, because we have to improve a lot our existing water mist system that we installed for oil and gas applications and in marine applications, because railway requires actually some specific characteristics. And last one are the full-scale fire tests. So also this system has been totally tested and certified in an Italian accredited laboratory in order to assess that distinguishing capability was consistent to the Italian standard. Now let's have a look exactly at the real equipment and how they works, and also at the physics control panel that we have created from this short video that we have recorded in 2017 in Milan during the railway exhibition. It lasts a couple of minutes.
Mark might have to try that again. Marco, can you hear me? Marco, can you hear me?
Yes.
Yeah, it's not coming up again. Do you wanna share the video? Actually, bring it back up. So if you share screen again, you'll be able to just go to the video and play it.
Okay.
Just close the PowerPoint and you can share the video. If you share again, just go and click on the video with the share screen. It worked before we began, so.
Okay, let's have here the video.
Yeah, just click on the video and it will play.
Can you see it?
No, we can't see it. Do you want to close the PowerPoint?
Okay, let me
Try and
from the beginning.
share the video again.
Okay.
No, it's not coming up. Why is it doing that? Have you shared the screen?
Yes.
No, it's not coming up, I'm afraid. I don't know why it's doing that again.
Okay, let me try to close the PowerPoint. Maybe let's restart the PowerPoint. Okay. Can you see it now?
I can see the PowerPoint that you've brought back up.
Okay, so let's start from here.
There we go. Perfect.
Okay. Can you see my presentation now?
Yeah, we're fine. Yeah.
Okay. So let's now just focus on the real tests that the Italian standard requires to be performed on board after the system is installed. This is a very challenging task because we had to provide a smoke source that have to be located in some in the worst conditions, and so in different conditions, maybe like under a table or under a seat and so on. Also, the system have to be validated in different environmental conditions. So with the air conditioning activated and not activated, also with some communication doors and entrance doors, in one case open and in another case closed. So in each time, the system have to prove to be reliable and always understand exactly where there is the fire source. And in total, we have done more than 60 real fire tests, changing the various environmental conditions. And what is very important is that also in each of these tests, according to the HARGE standards and the Italian standard, the detection system have to receive a pre-alarm signal within 1 minute, but also an alarm signal by 1 minute. That is actually very, very challenging because the system have to be very smart, and this is most of the job that we have done. So to work out the software of the detection system that was needed to very quickly understand where the fire was located. One look at the validation of the firefighting system that, as said, we have done at the LAPI laboratory in Italy. We have done fire tests to prove that the same condition installed on board was able to meet the standard criteria. So we validated the nozzle spacing, most of all, and the minimum working pressure at the nozzle, that is 60 bar, and the use of pure water, because no additives are actually allowed. During the test, of course, for the entire duration of 15 minutes, the system have to be able to maintain a temperature lower than 65 degrees C, and also the concentration of the toxic gases have to remain lower than the maximum allowed by the standard. So there are different configurations foreseen by the Italian standard. The whole configuration for the passenger areas, the compartment configuration for the toilets, and another lockers. So the Italian standard is very precise in describing the condition. The fire tests have to be carried out, and so the documentation and the reports to be produced. As said, this activity have been done on existing train while they were on ordinary maintenance. So we can see that starting from the existing ceiling, we removed the ceiling and then we modified them while we were installing also cables, modules, and piping and nozzles. And on the right, you can see the final configuration of the coach as it is today while it's traveling. The other difficult task was actually to find out a place for the cylinders. So this is the typical water and nitrogen package, and the orange one is the control panel. So we modified an existing luggage area. We only took a little bit of this luggage area, and you can see on the right the actual configuration. So still we have a luggage area, but here in this locker we have all the equipment that you can see in the middle. And just a final look at two very important tasks of railway firefighting projects. So the seal level and the ramps. So according to the Italian standard, the detection system and the electronic actuation of the firefighting system have to have a reliability level up to SEAL 2, because of course the system always have to be available when there is a fire. So we have to execute several tests in various laboratories to assess that how our system was at least able to reach the SEAL 2 level. The other important characteristics is the RAMs. So very important today, and also is a specific requirement of the Italian standard. The firefighting and detection system have to demonstrate to have reliability, availability, maintainability, and safety according to the levels required by the European standard EN 5126. This is very, very important, and because the operators actually need to be sure that the life cycle costing of the system that we are going to install actually are inside certain parameters. So RAMS definitely is a key performance indicator that is on the attention of most the operators and the railways authorities nowadays. In conclusion, this kind of projects not only have to take in consideration typical railways standards, but also have to make reference to standard civil firefighting standard as EN 54, EN 15004 for gas extinguishing system, and also they make usually reference to international water mist standard such as NFPA 750, but also marine standards, because this is the base where the water mist technology started about 20 years ago. So IMO 800 and IMO resolution 265 also are reference for the fire test scenario that we have in the Italian standard. So this is a final evaluation on the reference standard. Thank you for your attention. We are available for any questions.
Giovanni, Marco, thank you very much for that. That was excellent. Marco, first question for you. How long does the retrofit take?
Well, actually, we have a very limited amount of days to take a train. We usually receive a complete train that is composed basically by 11 coaches, and the train is dismantled, and we receive each coach in each different working location. So we have about 4 days to complete each coach. And then when all of them are finalized, the train is reassembled, test that the CAN connection, the Ethernet connection is working properly, and then the train returns to its daily business.
Thank you, Marco. Another question here from Gail. How many liters of water do you need in passenger area to fight the fire according to UNI requirements?
It is not specified how many liters. It is specified that you need to provide the amount of water that during the fire test in the laboratory, you need to take the fire under control for 15 minutes. Let's say it is 70 liters. On top of that, you have to have a safety of 10%. So you have to provide 77 liters. So it is not a specified amount of liters. It depends on the testing plus 10%.
Okay, Marco, thank you very much. Next question. When was ETR 500 created?
Well, for it, as a train is pretty, let's say, as some years. I think, I'm not sure about 15. I don't know if Giovanni recalls better about that.
No, I agree. Mark, is about 15 years project. Of course, we work on the firefighting since on the train in the TR 500 since 2017. So it is an old train, but with a new retrofit a few years ago.
Thank you. Giovanni, I know you answered this question, but I will ask it for everybody else. With regards to your video, brilliant video just now, how recently was it taken and was it done at your own facility?
Yeah, it was done in our facilities, in our testing area that I told before, it's one of the biggest in Europe. And it was taken at the end of 2016, so beginning of 2017, maybe to end of 2016.
Thank you. Another question for you. Which country specific to rodent stock only are you active in?
Basically, our major market, it is for the Italian Trenitalia, so for Italy. But then the trains can, of course, go also in different countries. But we are also active in India. We are doing some jobs over there. And in some other country in Eastern Europe. But our main target for the moment is the Italian market with Trenitalia.
Okay. And as I saw in the presentation, you do this for metro tunnels as well?
Yeah, of course.
Yeah.
Yeah, we have a specific system for the tunnels, for the metro tunnels, that is based on the same concept of water mist, high pressure or low pressures, to cover the risk of fire inside the tunnels. So the concept is the same. Of course, the system is a little bit different.
Yeah, we have, I would like to also add a detail. We have a system also for the road tunnels. We have a system for road tunnel and another system also for metro tunnel. Of course, they are slightly different also for the firefighting purpose.
Okay, guys, many thanks. Another question for you. ETL 500 system is developed according to UNI standard UNI 1156-5. Any revision is forecasted for the standard, and do you know the main points of the revision?
Well, actually, there is a revision in progress. I think the main important part that is under discussion is to provide also fire test for let's say machinery spaces, because now passenger areas and are present on the actual let's say issue of the standard. The next revision will focus more on machinery area standards. So where they, for example, in trains where you have diesel traction, not electrical.
Okay, many thank you. I've got a question here from Bazaar. Is it possible to provide low or intermediate pressure water mist system instead of high pressure one?
Well, intermediate should be something like 30 bar from probably from 20 to 30 bar. In this case, not, because the requirement on the Trenitalia specification was focused on the high pressure. So with this kind of configuration, usually reducing the pressure, you need more water. So the systems tend to have a bigger impact on when the installation inside the coach, and we also believe that the efficiency is not the same as the high pressure.
Thank you. I have another question for you. Do you have evidence of the performance of the system after installation? Any real fire happened on board?
Well, actually, yes. We have been informed about a couple of fires, but in the technical spaces. Of course, there the probability of fire is higher. So we had fire in a technical space, I think, and the thermal cable detected the fire, and the aerosol cartridge actually made his activity. So at the end, what is good from this information is that we have seen that after the test, the residual that we have found in the area created by the aerosol is really consistent with our design and our previous tests, because we have done also real tests in the technical spaces activating the aerosol. So actually we found the same results that are satisfactory.
Thank you very much. Another question for you guys. So how long have you serviced rolling stock OEMs with fire safety?
But the activity of especially Silvani since many, many years, also with some other different small firefighting systems. We can say we started about 20 years ago. But of course, the major reference is the work that we are now currently doing, because it's not yet finished. The work on this ATR 500 is the one that is about ATR 500. So it started the activities at the 2018.
Okay, many thanks. Another question for you. During the study activities of the system, have you considered the simulation with FDS software, to optimize the WM system as discharge quantities?
Well, very good question. Yes, in our R&D department, we use this device and then, let's say, a design possibility to optimize our system. Of course, as required also by the standard, this work have to be in parallel with the serious and challenging real fire testing activity. So, but of course, definitely simulation is a good tool to limit the amount of hours that we have to spend really in the laboratory. Also, from the Italian standard, I think is accepted in some cases to approve your system, your project for the detection system only by simulation.
Thank you very much, Marco. Another question for you. Can you describe more how the control panels for the detection system are arranged, and where these ones are located on board?
Yeah, as said, at the end we decided mainly for maintenance purposes to group together all the modules in the same place with the two redundant controllers. So we have a global and a unique control panel. It is about 60 centimeters wide, and it is located in the same place where we install the cylinders. So it is located at one of the sides of the coach. So we have the cylinders, and installed on the panel in a vertical position, there is also the control panel. So it is accessible from the inside, from the outside, from the corridor. You can open a small door and you can see the control panel and the various displays. So if there is an alarm, you can immediately see what is the reason.
Thank you, Marco. Another question for you. If allowed, can you please reference any rolling stock or operator customers using your systems?
Yeah, okay. Our first operator is, of course, Trenitalia. We have worked for Trenitalia and also for other different company of the same group, because we have done also some other trains for the group of Trenitalia, like the so-called Freccia Verde, that is the train for material, not for passengers, or the test train that they have on the railways, the network. Of course, we are working also with a different operator, but mainly also we are starting to work with some producers, from some OEM producers. So maybe we can share this information later on, but of course, first our customer is at the moment in Italy.
Thank you very much, Giovanni. Another couple more questions for you. Can you describe what kind of fire source have been used to test the detection system on board?
Well, considering that the detection that we were using was a combination of smoke and heat, actually we used the smoke source that is required by the Italian standard but increasing the heat that is needed to actually create this effect that allows the smoke to reach the detectors level. So basically is the smoke source that is referenced in the Italian standard with with a heat generator headed.
Thank you, Marco. Does Valvitalia have any future innovations you can talk about that they might be seeing in the year, 2, 3 years down the line?
Yeah, we invest a lot of new product and new innovations. So we are working daily to see how, for instance, we have one of the most efficient nozzles on the market, especially for the marine sector. So we used to develop every year some new products. And also on the train, we are thinking to work especially on the control panel. To develop some new technology also for remote control in this field. So it is a continuous improvement.
Okay, Giovanni, thank you. In your video, Giovanni, the test, do you do tests a lot? Is it once a month, every couple of months? When do you do those?
No, usually every, let's say 6 months, we make a very big testing event for our customers, but not only for the customer, but also for the local fire brigade, also because sometimes they use our test to test their systems. So every 6 months, we used to make this kind of event. Of course, during this year, we cannot do it for the problem of the coronavirus, but usually every 6 months we have this event.
Thank you, Giovanni. We've got another question here. The scope of system designed is for improve the escape of the passengers and get out of the train. Is this correct scope? Is the correct scope, sorry?
Yes, actually, this is exactly what is required by the standards. So in case the train has a fire and it is right inside in the middle of a tunnel, the water mist have to provide coverage and protection for the passengers for 20 minutes. That is the amount of time that is calculated to be needed for the passengers to evacuate the train.
Thank you, Marco. Final question for you guys. Diagnostic. How are the onboard detected alarms transmitted to the owner maintenance center?
Well, as I said briefly before, we develop an hub that is able to receive and elaborate all the information sent by the two controllers. And based on this information, it creates graphics and make available an enormous amount of information that via web we transmit to the maintenance facility and also to our colleagues that are dedicated to do the daily maintenance of these vehicles. So it's very important that this is one of the points that we are investing also more for the future, because is a tool very, very important. So because you can always see what's happening inside the train, or also what's happened in case of a fault. You can try to see and what exactly happened that day in that minute. So if there was someone, for example, smoking in the entrance area, you can understand, because starting from suddenly, immediately, you see that there is an increase in smoke level, and after 2 minutes goes to zero. So it is clear that someone inside the train or outside with the open door started to smoke.
Marco, thank you very much. Ladies and gentlemen, I would like to say a big thank you to Giovanni and Marco from Valvitalia for an excellent presentation today and a superb Q&A session. The webinar today will be on demand for you to rewatch. Thank you to everyone attending, and once again, a big thank you to Giovanni and Marco from Valvitalia. Guys, I'd like to wish you a very Merry Christmas. Stay safe and look after yourselves. And that is to everybody else for attending. Many thanks to all, and we look forward to seeing you all at our next WeRail webinar. Thank you all. Have a good day and goodbye.
Thank you, Martin. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.